This next definition dates back to 1968 with the Truth in Lending Act about interest rates having to be disclosed to consumers. This is the effective rate of interest. It's going to be the annual rate of interest that, when compounded annually, will yield the same accumulated amount as the nominal or the named rate compounded m times per year. Thus, we can put any given rate at any compounding frequency in terms of an equivalent rate that is compounded annually. So in other words, we can level the playing field and actually see what we're purchasing. This effective rate of interest is also called the annual percentage yield. And if you'll Google best APY on current accounts, you'll see a lot of advertisements with APYs on them, and so now you'll know what they mean. REFF stands for the effective rate of interest, of course. And R is going to be our nominal or our named or advertised rate per year. And M is going to be our number of conversion periods per year. Before we fill in the formula, let's consider the accumulation formulas with t equals 1. So let's start out with simple and compound interest. So your simple interest formula is P times 1 plus RT. And instead of using that little r, and instead of using t, remember t is going to be 1, and we're going to call that a capital R, just for the sake of doing some comparisons here. And then again, t is equal to 1. So over here, A is equal to P and then 1 plus R over I to the N, where I is R over M and N is MT. And again, we're going to let t equal 1, so let's see what we have here. We've got P and then 1 plus R over M. And then t is equal to 1, so we just got an m power. Well, a is equal to this and a is equal to this, so let's set these two equal to each other, and we'll have p times 1 plus r is equal to p times 1 plus r over m to the m. And notice we have a factor of p on both sides, which means we can divide both sides by p, and they'll cancel out on both sides. So divide both sides by p, and we're left with, I'm going to move it over here, 1 plus r is equal to 1 plus r over m to the m power. And if I wanted to solve for that capital R, then that means I could just subtract 1 from both sides. So subtracting 1 and subtracting 1, that's what gives me the REFF formula. So this is considered to equal REFF. So let's put that in the box. We're going to take 1 plus r over m, we're going to raise it to the m power, and we're going to subtract 1. And that formula will be given to you on a test. Practicing a few, we're going to round to 2 decimal places, but not until after we've converted to the percent. Find the effective rate of interest corresponding to the named rate of 2% per year, compounded semi-annually, quarterly, and monthly. Remember, this is 2 times a year, this is 4, and this is 12. So we've got REFF equal to 1 plus r over m to the m power, and then minus 1. So REFF is equal to, we'll have 1 plus, R is going to be the 2%, so 0.02. M is your number of compounding periods in a year, so semi-annually is 2 to the second power, and then minus 1. Let's go ahead and get all these written down, and then we'll type into the calculator 1 plus, and we'll have 0.02 again. This time my M is going to be 4 times a year, so this is also going to be a 4 exponent. And lastly, 1 plus 0.02, and then over 12 to the 12, and then minus 1. So r over m to the m. All right, let's type all these in. We can do the first one and then do that trick of second enter. So parentheses, 1 plus, don't forget the fraction has to have parentheses, 0.02 over 2. Close that parenthesis and square it because we've got a 2 up there. And then let's go ahead and subtract 1. 0.0201. Remember, do not round until after you convert it to the percent. So multiply by 100, that's going to give me 2.01%. And I don't need to round because it's already to 2 decimal places. Doing the same thing for 4, so second, enter, and let's just change that 2 to a 4. And we'll have to do a little bit more work on the square, so we're going to change it to a caret, and then second, delete to insert, we need to change that to a 4. And then hit enter. 0.02015. Now, it only told me to round to 2 decimal places, but I may have to do some comparisons at some point, so it might be beneficial to keep track of how many extra little numbers we have out there. So if we rounded this one to 2 decimal places to a percent, we'd have 2.02%, okay? But we could also keep track in our head that this was really 2.015%. So let's see how it compares to this one here. Second, enter. Again, we could just kind of change these numbers, turn the 4 into a 12, but you can only turn the 4 into a 1, and then you have to second, delete, insert a 2 to get the 12. And same thing with the exponent, change the 4 into a 1 with second, insert to do the 12. So we got 0.02018. All right, so rounding to 2, let's see, 2.02. So we would have to be careful here if we were comparing these two, and I would make myself a note that this was 2.018%. So this is a higher percentage rate than that one is, but here it looks like they're exactly the same. So we actually see us doing that in example 11. We've got Fleet Street Savings Bank paying an interest rate of 4.29% compounded weekly, and Washington Bank 4.19% per year compounded daily. And we're trying to determine which bank offers a better rate of interest based on the APY. So let's do Fleet, and then let's do Washington over here. All right, so we need REFF for both. So your formula, all right, so for the first one, we've got 1 plus. Let's see, Fleet does 4.29% per year, so that's 0.0429. And then it's compounded weekly. So how many weeks are in a year? Well, there's 52 weeks in a year. And then for Washington Bank, they're 4.19%. And they are compounded daily. So let's see what happens with these two. Alright, so it looks like Fleet's coming up with 0.043815. We'll just carry it out several places before we change it over. And then let's change this one to 36, and then second, delete to get a 5 in there. And same thing with the exponent, 36, and then second, delete to get a 5 in there. And let's go ahead and hit enter for that one. This is a slightly different concept from the previous one. This is the effective rate of return. You may also hear it called the annual effective yield. This one uses the formula A equals P times 1 plus I to the N, with M equal to 1 and solving for R. So we'd have A is equal to P times 1 plus R over M to the MT. And we've got M is equal to 1, so putting 1 in there, we've got P 1 plus R over 1 to the 1 times T, which is just 1 plus R on the inside. Then we can divide both sides by P. And we can solve for R. So remember, if this was a square, we could take the reciprocal root. Like if it was a square, we could do a square root. If it was a cube, we could do a cube root. So we could raise both sides to the reciprocal root power. So A over P to the 1 over T. That would leave me with 1 plus R, and then I just need to subtract 1. So this is going to give me R sub EFF again. It's still an effective rate. Is equal to A over P to the 1 over T minus 1. A quick little example before we close out. Martha invested $40,000 in a boutique 5 years ago. Her investment is worth $70,000 today. What is the effective rate, the annual effective yield, in other words, of her investment? So this is how we know we're looking for this particular formula. Also, it gives us the worth before and the worth after, so we've got those before and after values. So A is the amount after, so that's going to go in the numerator, so 70,000. And then P is the previous value, what it started out initially, raising it to the 1 over T value. Okay, so the reciprocal here, 1 over T, and then minus 1. Well, we can make this easy on ourselves and just cancel out some zeros, couldn't we? So basically 7 over 4 to the 1/5 power, and then minus 1. So we'd get 0.1184, and this is going to be, as a percentage, around 11.84%.